In this video I'm going to continue on solving equations which make use of a sketch of a trig curve and a calculator to help us solve a trig equation. Okay, I'm going to do a question 4 which follows on to the 3 previous examples, and this one has got a slight twist in it, so we need to be a little bit careful. Okay, so part A, sketch y equals sine x. Well, that's very straightforward, in the range 0 to 360. So let's do that quickly. Part A, here is a sketch of the y equals sine x graph. I'll just do this, and remember, you do the basic curve first, there it is, and you put the values on the axes in afterwards for your sketch. So that's 1, that's minus 1, that's 0 degrees, that's 180 degrees there, that's 360 degrees. It will also help you if you mark in that central point 90 and the trough is at 270. So there's your basic sketch of y equals sine x. You've done part A, you get 2 marks or whatever for that part. Part B now says hence solve this equation, and obviously hence means you've got to use this sketch to solve it. The sketch on its own will not be enough because it's not accurate, so you've got to use the sketch in combination with a calculator to get the answer, as we've done in previous questions. Okay, so I'll write down the equation again. Sine of x equals minus 0.3. So you're expecting, if you have looked at previous videos on the first 3 examples, to get a couple of answers for this within the range 0 to 360. 2 answers. So let's have a look at what the calculator gives, and then we'll have a look at the sketch. So if I take my calculator and I do shift sine of minus 0.3 and then press equals, I get an answer x equals minus 17.5 degrees to 1 decimal place. I've approximated that. So to 1 decimal place I get that. Okay, so in the past we've been doing these, and that's the first of the answers, and then we use symmetry of the picture to get the second answer. So let's see what happens in this particular example. Okay, so in this particular example I'm now going to use my sketch with that answer to get the 2 answers. So I need to plot a graph of y equals sine x. Well, I've got the sketch of that, done. I also need to plot a sketch of y equals minus 0.3. Well, that's just a horizontal straight line. So you go to minus 0.3, which is about here in your picture. Indicate that on the scale in the approximate right position. Once again, it's not accurate, it's approximate. And minus 0.3 y equals is simply a horizontal line like so. And you label it like so. And as you can see, we get 2 answers, as expected. 2 answers again. And the 2 answers will be there and there, where the intersection of the straight line and the curve exist. And to get the 2 answers, you need to read up to your x-axis in these 2 positions, there and there, like so. So, no problem. Here we go then, let's use the symmetry of the curve. You can see we have got a problem because the first answer, minus 17.5, well, looking at that, that is definitely not minus 17.5. That is an answer more than 180, and that is an answer very close to 360. So what the calculator gives is not corresponding to one of those 2 answers. So how do we get around this problem? It's very straightforward. If you think back to the first videos that I did where we actually plotted accurately y equals sine x graphs, and we didn't actually stop it at 0 to 360 degrees, but we continued it on, the actual sine wave gets repeated over and over and over again ad infinitum, forevermore. But not only does it go on forever as the angles get bigger and bigger and bigger, every 360 degrees you get the same shape, remember? But if you actually went backwards, as I discussed in a previous video, into the negative angles, you get the same shape being mapped out on the negative angles. So for this particular question, if I've got a minus 17.5 from the calculator, what I want to do is draw a bit of the picture with the negative x angles on it to be able to help me use the symmetry to get the actual 2 answers. Let me show you what I mean. I'm going to take a colour and I am going to extend the axes on the negative scale. And I'm going to extend in a colour the sine graph, which I only wanted for part A between 0 and 360, but I'm going to extend it now like so as a cycle into the negatives. So over here would be minus 360. That would be there minus 180. This here would be minus 90. And what I'm going to do is extend my straight line to cross. I'll get rid of that so you can see what's going on. That's minus 0.3 on the value there. I'm going to get it going like so. And what you'll find is that actually this straight line cuts the curve there and there, but it also cuts the curve there and there as well. But normally, because these angles are negative angles, we wouldn't bother drawing the picture because the range is 0 to 360. I'm only concerned with the ones that lie in this part of the picture. However, because the calculator is giving minus 17.5 as your answer, what you need is to look at these negative angles and realise that that answer there is the one that the calculator is actually quoting you, which is minus 17.5. We now, based on that negative angle the calculator has given, use the symmetry of this situation. I'm just shading in this region there. That's the same as that region there, and the same as that region there from symmetry. We now use this fact to help us work out the two angles we want, which actually lie within the range 0 to 360. So let me show you what I do. That is 0 degrees, that's minus 17.5. So the gap between them in this little region here is a 17.5 degree gap. From 0 to minus 17.5. That means that the gap from there to there must be 17.5 from symmetry. Also, the gap from there to there is 17.5 degrees from symmetry. Okay, I can now work out the two angles I need in the range 0 to 360. That value on the scale is 180. That gap is 17.5, so it's another 17.5 further along. So the reading that I would read off, if this was an accurate picture, would actually be not 180, it's 180 plus 17.5, 197.5 degrees. And that is the first of the answers we need in the range 0 to 360. The second answer, well, that there is 360. The gap is 17.5, so I need to subtract this time 17.5 off 360. 360 take away 10 is 350. Take away another 7 is 343. Take away another 0.5 is 342.5. So that value there would be, I can't really write it, well I'll try, I don't know if you can see it. It's 342.5, that point there. So the final answer, 342.5. Now don't make the mistake now of thinking, yep, done it, sorted, let's move on. Don't forget, I'm only allowed to quote answers in the range 0 to 360. That one is fine, but that which the calculator gave us is not allowed because it's a negative answer, it does not lie between 0 and 360. So I would cross that out. And there you go, they are the two answers that we get in the range 0 to 360 for this equation. So this is something that you need to master. Sometimes, on occasions, there's the graph between 0 and 360, but the calculator gives you an answer which doesn't lie between 0 and 360, so I needed to extend the negative part of the graph and then use the symmetry to get the two answers within the range that I require. So this is a more advanced question and does sometimes cause a few problems for students, and it does mean a bit of practice is required. Okay, that's the end of this short video.